You type a question into a chatbot, it answers in 2 seconds. The answer sounds thoughtful. It sounds like someone considered your feelings, weighed the options, and wrote you something true. It didn't. There was no thought. There was no consideration. There was math. A horrifying, beautiful amount of math, repeated billions of times in under a second. And somehow, that produces something that feels like a mind. But the real reason it feels that way is far weirder than anyone in Silicon Valley wants to admit on a podcast. So what is actually happening in there? Let's start with the lie everyone believes. People think an AI model understands what you're saying. It doesn't. Not in the way you understand things. What it's actually doing, underneath all the marketing language, is predicting the next word. That's it. That's the whole trick. You type, "the capital of France is," and the model isn't recalling a fact from a mental map of Europe. It's calculating, across every word it has ever seen, which word is statistically most likely to come next. It just so happens that Paris wins that calculation almost every time, because in the ocean of human text the model was trained on, Paris always follows that sentence. This is called a large language model, or LLM for the people who like acronyms more than syllables. Large just means it was trained on an obscene amount of text. Books, websites, forums, code, arguments people had on Reddit at 2 a.m. that they regret. Language model just means it learned the patterns of how language flows, one word at a time, like the world's most well-read parrot with zero understanding and excellent recall. Here's where it gets stranger. To predict the next word, the model doesn't read your sentence the way you do, left to right, like a person scanning a page. It uses something called a transformer, a type of neural network architecture introduced by Google researchers in a 2017 paper called "Attention is All You Need." That paper, written by Ashish Vaswani and his colleagues, is the reason every AI chatbot you've used in the last few years exists at all. It quietly became one of the most influential pieces of computer science writing in the last decade, and almost nobody outside the field has heard of it. The attention in that title is the key. Instead of reading a sentence in order, the model looks at every word at the same time and calculates how much each word should pay attention to every other word. In the sentence, "the trophy didn't fit in the suitcase because it was too big," the model has to figure out what "it" refers to, the trophy or the suitcase. Humans solve this instantly. The model solves it by running a calculation that weighs the relationship between every pair of words in the sentence, billions of times, across every sentence you've ever typed to it. Billions. Per response. That number isn't a metaphor. It's not billions the way your uncle says traffic was a million cars. Training a model like GPT-4 reportedly involved processing trillions of words and required computing power that, according to public estimates, cost well over $100 million in compute alone. You're talking to something that cost as much to build as a small fleet of jet aircraft, and it's using all of that to guess your next word correctly. Question: if it's just guessing, why does it feel like it understands you? Because guessing well enough, at a big enough scale, starts to look identical to understanding. This is the part that should unsettle you a little. There's a famous thought experiment from philosopher John Searle called the Chinese room. Imagine a man in a room with a giant rule book. Someone slides him a note in Chinese under the door. He doesn't speak Chinese, but he looks up the symbols in his rule book, follows the instructions, and slides back a perfect response in Chinese. To the person outside, it looks like fluent understanding. Inside the room, there's just a guy following rules with zero comprehension. Searle wrote that thought experiment in 1980. Decades before anyone had built a machine that actually did this at scale. He was describing ChatGPT before ChatGPT existed, and he was trying to argue it doesn't really think. A lot of AI researchers still aren't sure he's wrong. Here's the twist nobody saw coming, though. Even the engineers who build these systems can't fully explain why they work as well as they do. You'd think the people who wrote the code would know exactly what's happening inside it, line by line. They don't. A modern large language model has hundreds of billions of internal values, called parameters, that shift during training to get better at predicting words. Nobody sits down and assigns meaning to each one. They emerge. Researchers at companies like Anthropic have entire teams dedicated to a field called interpretability, whose entire job is reverse engineering what's happening inside a model they themselves built, like archaeologists digging through ruins of a city they constructed last year. That's not a joke. That's the actual job title. And sometimes what they find is bizarre. Researchers have discovered individual clusters of artificial neurons inside these models that seem to represent oddly specific concepts. One for the Golden Gate Bridge, another that lights up for deception, another tied to a vague sense of things that are slightly off. Nobody programmed those in directly. They formed on their own during training, the way patterns form in clouds, except these patterns can apparently detect when you're lying to them in a chat box. So, is it thinking? Here's the honest, slightly annoying answer. It depends what you mean by thinking. If thinking requires awareness, feeling, or caring whether it gets the answer right, then no. The model doesn't care if it's wrong. It has no stake in your homework, your breakup text, or your business plan. If thinking just means processing information, weighing relationships between concepts, and producing a coherent, contextual response, then technically, yes, in a way no human brain has ever done it, using math instead of neurons soaked in chemicals and caffeine. Maybe the real answer is that thinking was never one clean thing to begin with. Humans assumed it was special because only humans did it. Then a machine came along that does something that produces the same output, a reasonable, context-aware sentence, through a completely different process, and now everyone has to argue about definitions instead of admitting nobody fully understood the original definition in the first place. There's a meme that's been floating around tech circles for a while: stochastic parrot. It means a system that mimics language patterns convincingly without any real understanding underneath, repeating back probability instead of meaning. Researcher Emily Bender helped popularize that term specifically to push back against the idea that fluent text equals a thinking mind. It's a fair point. It's also a little bit cope, considering how often that parrot outperforms actual humans on writing, coding, and exam questions it was never directly trained to answer. Which brings us back to you, typing into the box, waiting for a reply that arrives in 2 seconds. You're not talking to a mind. You're talking to the output of a staggering, almost incomprehensible amount of statistics, trained on the collective writing of millions of humans, none of whom agreed to teach a machine how to sound like them. And somehow, when it answers, it still feels like someone's home. Maybe nobody's home. Maybe that's exactly the most human thing about it, built entirely out of us and still somehow a stranger.